What's up, tech enthusiasts, and welcome back to MetaVerse Update. Get ready, because the future of computing is here and it's absolutely mind-blowing. We're diving headfirst into the latest breakthroughs that are reshaping reality as we know it. First up, we're exploring the groundbreaking fusion of quantum computing systems with traditional high-performance computing systems, an overview that details how these distinct paradigms can work together to tackle previously unsolvable problems. Next, we've got some massive news that's sending shockwaves through the quantum world. PsiQuantum has just announced a monumental $1 billion raise, a Series E funding round that's set to propel their ambitious plans for utility-scale quantum sites and the advancement of their photonic chips. And speaking of quantum chips, we're digging deep into PsiQuantum's record-breaking funding and their unique approach to building fault-tolerant machines. They're not just talking about the future. They're building it with mass manufacturing best-in-class quantum photonic chips, and this massive investment is fueling their journey to a million-qubit scale machine. Finally, we're connecting the dots between these quantum leaps and the future of artificial intelligence. Discover how PsiQuantum's advancements, backed by major investors like BlackRock and NVIDIA, are poised to revolutionize AI and beyond. Stick around, you're going to want to see this. Make sure to like, subscribe, and hit that notification bell so you never miss a beat on the metaverse and beyond. The future of computation is hybrid. Get ready, because the way we process information is undergoing a seismic shift. Researchers like Konstantinos Rallis, Ioannis Liliopoulos, and Georgios Varsamis are at the forefront, detailing the intricate dance between quantum computing and high-performance computing systems. This isn't just theoretical. It's about architecting the next generation of computational power by merging the unique strengths of both classical and quantum realms. They're exploring everything from the fundamental hardware designs and software frameworks to the practical applications that could unlock solutions to problems once deemed impossible, especially in complex fields like optimization and machine learning. The community is buzzing about this convergence. Analysts are highlighting the strategic importance of integrating quantum capabilities with existing HPC infrastructure, noting that this hybrid approach is crucial for tackling large-scale scientific challenges. The research underscores the potential for unprecedented breakthroughs, but also acknowledges the significant engineering hurdles that must be overcome to build these powerful, interconnected systems. But that's just the beginning of our quantum journey today. Next, we're talking about a funding round so massive, it's rewriting the rulebook for quantum startups. PsiQuantum just secured a staggering $1 billion in funding. In a move that underscores the explosive growth and investment potential in quantum technology, PsiQuantum has closed a monumental Series E funding round, raking in a cool $1 billion. This isn't just pocket change. It's fuel for their ambitious mission to construct utility-scale quantum computing sites in Brisbane and Chicago, and to push the boundaries of their photonic quantum chips and fault-tolerant architecture. This landmark investment, led by giants like BlackRock, Temasek, and Baillie Gifford, values the company at an eye-watering $7 billion, attracting a host of new high-profile investors, including NVIDIA's venture arm, N-Ventures. What's driving this massive confidence? PsiQuantum's CEO, Professor Jeremy O'Brien, emphasizes their focus on building the real thing, million-qubit scale, fault-tolerant machines, framing it as a grand engineering challenge. Their unique approach leverages the strengths of photonic qubits and high-volume semiconductor manufacturing, aiming to bypass the typical scaling hurdles in quantum computing. The integration of advanced materials like barium, titanate into their manufacturing process for optical switches is a critical step, potentially unlocking ultra-high-performance optical networking not just for quantum, but also for next-generation AI supercomputers. This incredible funding is paving the way for PsiQuantum's ambitious build-out. Now, let's dive deeper into exactly what this means for the future of quantum chip manufacturing and their race to 1,000,000 qubits. PsiQuantum is building the future, one photon at a time. PsiQuantum isn't just raising funds, they're laying the groundwork for a quantum revolution. With their $1 billion Series E investment, The company is set to break ground on utility-scale quantum facilities and accelerate the development of their fault-tolerant architecture. Their core strategy revolves around photonic qubits and leveraging established semiconductor manufacturing processes, a path they believe offers the fastest route to creating the million-qubit scale machines essential for unlocking quantum computing's true potential. This approach is distinct from many competitors and has garnered significant backing from major players like BlackRock and NVIDIA. The implications of this funding are vast. PsiQuantum aims to have its ambitious machines built by 2028, positioning them at the forefront of a rapidly evolving quantum landscape, alongside competitors like IBM and Google. Their unique integration of barium titanate for high-performance optical switches and their novel high-density cooling solutions, designed to mimic data center racks rather than traditional cryostats, highlight their commitment to practical, scalable engineering. The collaboration with NVIDIA further solidifies their position, focusing on quantum algorithms, software, and GPU-QPU integration. This massive investment and unique approach are setting PsiQuantum on a course to redefine quantum computing. But what does this mean for the AI revolution that's already underway? PsiQuantum's record $1 billion raise is set to build the world's first utility-scale quantum computers. In a landmark achievement for the quantum computing sector, PsiQuantum has announced a record-breaking $1 billion in Series E funding. This massive capital injection is earmarked for constructing their pioneering photonics-based, fault-tolerant quantum computer facilities in Chicago and Brisbane, Australia. The valuation of the company now stands at a formidable $7 billion, a testament to their progress and strategic vision, with lead investors including BlackRock, Temasek, and Baillie Gifford, alongside strategic participation from NVIDIA's venture arm. PsiQuantum's distinct bet on photonics, utilizing light to generate, manipulate, and measure qubits, sets them apart in a field where other major players are exploring different avenues. This choice is driven by the potential to leverage existing high-volume semiconductor manufacturing infrastructure, offering a potentially faster and more scalable path to quantum advantage. The company is focused on developing advanced quantum photonic chips, manufactured by global foundries, and incorporating critical components like barium titanate for high-performance optical switches, which are key to scaling optical quantum computing. This funding will also support their development of specialized cooling and networking systems, moving away from traditional bulky cryostats towards more integrated, data center-like solutions. With this incredible backing, PsiQuantum is accelerating its path to building machines capable of tackling humanity's biggest challenges. Now, let's recap all the incredible quantum news you need to know this week. And that's a wrap on your MetaVerse update. We saw how researchers are bridging quantum computing and HPC systems, PsiQuantum securing a massive $1 billion to build utility-scale quantum computers, and PsiQuantum's innovative photonic chip manufacturing paving the way for a million-qubit future. Don't forget to smash that like button, subscribe to the channel for more cutting-edge tech news, ring that notification bell so you're alerted to every new upload, and drop a comment below to let us know your thoughts on the future of quantum. You can also follow us on all our socials for more daily updates. We'll see you in the next one.